Hello YouTube, sorry if you did get a notification and there was no video because I'm using another phone since my Note 4 finally gave up to work, and my wife's phone is a Huawei or however you pronounce it, and with that I cannot transfer the videos to my PC. And then I used another person's phone, and that one had just terrible quality. So now this is an old Samsung, I don't know what, it's a real small phone, but I'm trying to make a video with that till I get something on my own. So here I want to introduce to you my H.E.D.S. family. I did receive new PCBs on Friday, and I couldn't finish neither one of them yet because I'm still waiting on parts. So mainly I did, let me start from the left, I did receive the front for the Color Can Gauge Mini. I'm still waiting on the carbon fiber fronts, so I figured meanwhile I will get a PCB version of it. This is I think 0.8 millimeters, and I did choose this time around, get something white here, to make the holes in a honeycomb shape, in a octagon. No, octagon said, I think hexagon shape. So, and they came out surprisingly well, considering this is a PCB, and so they're not bad. And the inner radius, they must have really used a small drill bit to mill it out, so it's not bad. And I like it. So once I get these probably redone, because I don't think the original carbon fibers will ever arrive. It's been over 3 months, so I mean 3 months waiting, that's a quarter of a year. That's crazy. So I will have to order new carbon fiber fronts. So that's that. The PCB I had of course before, and this is my new, I call H.E.D.S.Trek. Before it was called H.E.D.S.Trek because it was using OLED display. And let me show it to you real quick. I hope I don't knock this phone out of the tripod because I'm glued it down there with the tape. So this was my first version, and this is the second version or new version. And it is slightly smaller, not as wide. I think it's 42 and 44 millimeters, and it will be thinner, and the side will be not open as like that. I had this one open because I had the NeoPixel here and whatnot. The side will be made with a frame, and it will be a white frame, like that, white transparent frame, because it has NeoPixels all around the bottom half or bottom part here around the encoder, and I put, just for fun, 2 additional one in the top corners since I had the room, and I figured why not. So it will have the same rotary recorder obviously. And this one will actually use the 2-inch IPS display with 320 by 240 pixels. So the bigger brother of this one. This is the 1.3 inch 240 by 240 pixels. So this will have, like they always say on cell phones, a bigger screen to front ratio. So obviously this is a much bigger screen with a multiple of the resolution and color plus IPS. So, and I made it black because I had to make the frame in transparent so the colors will shine through as they do on my keypad. You might have seen it. So this is the new H.E.D.S.Trek, I call it, and this is the PCB for it. And let me quickly tell you the features of it. I have written it down somewhere here. Okay, here it is. So as I said, it has the 2-inch IPS display. It will use the Atmega 1284P chip, which has way more storage space and program space than the 328 previously used. It will have the rotary encoder. It will have a USB Type-C connector, and I'm going away from the micro SD from the micro USB port to Type-C from now on. And it has a USB to TTL adapter chip. It has an LDR. This is actually, was it? Yes, that's the opening for the LDR, so it won't stick out or some and such. I can see nothing in this phone here, so that's the cutout for the LDR. It has, it has a ADXL345 accelerometer chip. It has the BMP 180 temperature and pressure sensor and humidity. It has, or it will have, Bluetooth here on the bottom, Bluetooth module for uploading code wirelessly or for data transfer. It will have a micro SD card slot, which will be underneath the USB down here, so it will be all on the same side of the device. And it will have, of course, the speaker, which goes over here, and these little things are very loud. I was amazed when I tried it. And it has 3 touch sensors. Where are they? Here, here, and here. Here is the on-off switch, and it has 38 kilohertz. I hope you're hearing my voice without trouble, because I'm going to the side of the phone. It has a 38 kilohertz infrared receiver up here. This part here, and it will have a 3 or 5 millimeter infrared LED. The receiver will make it possible so you can learn any remote that you have, and then use this as your remote for any device that you like. I will use this for my TV, because on my TV I have to use these buttons and it's just a pain in the butt. I want something easier to use, and the rotary encoder is very easy. With one finger you can rotate it. And the NeoPix, as I said, it has 800 milliamp LiPo battery. It will have USB and wireless charging, and I will make actually a deluxe version or upgrade. Okay, now I just got a warning for low battery. I think this phone has the same problems with batteries. Okay, it will have a carbon fiber front also as an option. And am I still recording? Yes, I am. I will stop the video here, attach a USB plug, and go from there. So this will be part 1. Till later. Well, If all goes well, this is the addition to the first video, so it will become a whole one video. So I think I left off or was finished with the H.E.D.S.Trek, not H.E.D.S.Trek, the H.E.D.S.Trek, and I will, as I said, I have not received the carbon fiber front panels, and I'm not sure if I will, but I'm waiting for over 3 months, and I will just reorder them again. And this time I will add carbon fiber for the H.E.D.S.Trek as well, so it will come in matte black and carbon fiber. So this is my two-way remote that I'm building, and this will be the size of it. It will have an antenna if it's the long-range version, or will be like this if it doesn't, if it's just a regular version on the long range. I know it goes up to 3 miles. The regular version I have to try out. I would not be able to tell you right now. And this is the PCB for it. This is for the module. I'm using an NRF24 transceiver module. And this also has all bells and whistles, including of course the 1.3-inch color IPS display, excuse me, the ADXL345, BMP 180, USB Type-C plug. It will have the 1284p mega chip, so there will be plenty of room to add anything on here. I did also add the vibration motor to it. These are used in cell phones as well, probably smaller than this, I don't know. So it will have vibrate, it will have a speaker, so you will get visual, audio and the vibration feedback. It has a single side emitting NeoPixel. This will also have the transparent frame like the H.E.D.S.Trek, so the notification LED will be able to be seen. And this is it, I think. I did explain more about it, I think, on my previous video. This is the counterpart for it, which will be mounted in the car. Has several inputs and outputs for the remote. It also has CAN bus capability, so it can be connected to the CAN bus, and then you could transfer data back and forth to that. Or you can add analog signals to your non-CAN bus car or vehicle. I'm thinking of motorcycles as well. It does have a RPM input for RPM RPM input of RPM. Oh, great. It has 2 analog inputs with a voltage divider, so 12 volt signals can be connected. It has several other regular 0 to 5 volt analog inputs. It has digital inputs and interrupt inputs, of course. And the module will be on the back again. It has room for 12 volt up to 20 actually DC to DC converter module. Canvas is here. It will use 3.5mm screw connectors, which will actually be on the bottom like this, and it has optional 1.3-inch display, which I don't think it will be used because this is sitting in the car. But actually you could even use this as a CAN bus gauge, so then the display would be of course useful. What else do I have on here? Oh, it has again the ADXL345 sensor and the BMP 180. ADXL could be used as a motion detection. If your car gets hit or is in an accident, it will be able to send you a signal to your receiver. You could measure the interior temperature of the car. You could use this as a remote start as well, or control your windows. You could even, if you're up to it and code it, use it for CAN bus control. Send signals to this and then over CAN bus connection control anything in the car by reverse engineering your CAN bus or your comfort CAN bus that controls your radio and windows and whatnot. So this is it. It could also be used as just a CAN bus module without the transceiver, and then you could add any kind of sensors or CAN bus capability to your car or vehicle or bike or plane or whatever. I will using one of these, of course, as well. I'm building this for myself as well, to add oil temperature and oil pressure gauge to my car, because it doesn't have it. It just has an oil switch, oil pressure switch. So that's that. And I made yet another CAN bus gauge, which is this red PCB. This is the size of actually maybe even small, I think smaller than my OLED CAN gauge micro. So actually this is smaller than the micro, but it has of course the 1.3 inch display. It's practically this in this size with 5 neopixels instead of the 10. And what else does it have? It has the touch sensors, of course, for going forward and backwards in the screen, in the menu. It has again the Atmega 1284 chip, so there is plenty of room. And it has an option for a Bluetooth module, so you could upload your code wirelessly to it, or download code or data from your CAN bus to your PC or phone or whatever you have connected to the Bluetooth module. And I think that was it on this one. It has of course LDR for auto dimming the display and the neopixels. So that's that. The yellow PCB is the new clock and GPS PCB, and it has now touch sensors instead of using mechanical switches. So that's the way to go from now on. I'm gonna use touch sensors, which can be momentary or toggled switches. And it has 5 neopixels for the alarm indicator, LED indicator, of course speaker, LDR for dimming the display, and it has a connection for my GPS / micro SD card module that I'm using. This is also used actually with my small PCB, which I use to make my tracker, which is this size, and the GPS module will then be connected to the back of the module. So this will be the clock / GPS, the new one. And the blue PCB, of course the colors will not be shown once it's in the enclosure. You will not be seeing the colors. I just did it because I wanted to have a visual indicator for myself to pick the right PCB right away, and just to have it in colors. I mean, it doesn't hurt. So this is my H.E.D.S.Maxi PCB, which has 3-in-1 function, or which can be one of the 3 products. It can be my gear indicator. Of course, all these all have the color display from now on. I'm going away from OLED displays or LED displays, if you like that better. So it has the 1.3 inch color display. It has 2 sensors here, It has connections over here which are used to cascade the spectrum analyzer, for example. It can be made into a spectrum analyzer. Here is the chip, the MSGEQ7 chip for the spectrum analyzer. I'm sorry, I'm repeating myself. It has 5 neopixels for if it's anything gonna be used on here. It can be my gear indicator, as I said, which protected inputs and whatnot, and MCP1 or 1117 LDO, which can take up to 20 volt input. And it has, of course, onboard again LDO for the display for 3.3 volts protected input, and this can be also made into a simple voltmeter. I did sell some of those as well. It has, of course, a connector for an audio jack, this one here, so you can connect it to your phone or whatever you want to use the spectrum analyzer for. It has the audio jack. It has, this one still has the micro USB connector, but vertical I'm sorry, vertical USB type, micro USB connector, so the wire goes out the back, including the audio wire. So you can have it in the front and then it goes out the back. And this is also the frame for it then. And again, I will have also carbon fiber carbon fiber fronts or front panels, and it will be like this little guy, obviously a little deeper because of the audio jack. Anything else about this one? I'm always forgetting what it does, and then I have to look. But it also has the LDR input if you want to have the display be able to dim. So that's that. This is my new Atmega 1284p development board, and I showed you the paper templates that I had like this. This is how I do it, front and back, and then I check if the parts fit and whatnot. And this will have USB Type-C connector, USB to TTL adapter, ISP connector for uploading code or bootloader, a reset switch. I will use these little guys with the extended stem, which are much easier to press. And the printing is this orientation. So, and this is the back, and I purposely did this using 0805 chips, so it can be hand soldered easily. Not everybody does have a reflow oven. It has also RX and TX LEDs right next to the USB connector, and it has some parts on the bottom because they don't fit all on the top, and I wanted to keep this as small as possible. It's 20 by 40 millimeters, and the distance between these two rows of pins is breadboard friendly, so you can plug it into a breadboard. And what else is on here? That's it. So this is a development board I want to make open source, and this is the PCB for the GPS module and micro SD card. I could also use it just as a micro SD card without the GPS. And this is the small PCB like I showed you for my tracker, and I think this was it on here. If you do have any questions, just leave them in the comments, and I want to thank everybody who supports me on Patreon and Banggood through my affiliate links. I greatly appreciate it. And I wanted to show you something else. I found some new wireless charger modules, and this thing is small. I am using, let's see if I can. I was using these ones. Obviously I cut around it to make it as small as possible. This would be as small as possible it will go. These are the pads that the wireless charging receiver pads that I use on the H.E.D.S.Trek and H.E.D.S.Trek previously. And I wanted to have the capability of wireless charging for the smaller PCBs, for these ones, on the clock or GPS for example, and these do fit. And you can see the coil is smaller, and I can just put the PCB on here too. And it has also I don't know what this is called, but this you put on the coil so it gets better reception, I would say now. And the way it will be is this will be on the back. So you have a, do I have a back piece somewhere? Yes, I do. So you have the back piece, coil goes over it, then you have this protection or whatever shield that is, and then the PCB, it's a very thin PCB, it's great, that will come on here, and then you have the LiPo, and then you will have the PCB with the actual electronics, and then the front of course. So this will be an option. I'm not including it on everything, but this is the new wireless modules, receiver modules that I found, and I like them because I can use them here. So I also have like you can get them really cheap. This is a charging pad, obviously. You connect your USB, and then it has a LED, and then am I still recording? Yes, I am. So you can just place your device on top of it and have it charge wirelessly. So I do like that, and I will also include it in my altimeter. And yes, I think this was it. As usual, I'm sure I did forget something, and I will mention it in the next video if I don't forget it at all. So thanks for watching, and thank you everybody that supports me. I greatly appreciate it, and I wish everybody a great week. Till next time, take care.